same way, here n is equals to 6 means we calculated, n is equals to 7 means, and in the same way, if n is equals to 7, number of sides is equals to 7, for example that is a heptagon, 7-sided figure, then how many line segments are there? Then 6 plus 5 plus 7-sided I am saying, so we need to calculate from 6 onwards. If 8-sided figure, we need to take from 7 onwards. If that is a 9-sided figure, we need to calculate from 8 onwards. Okay, so here what is that? 7-sided figure I am saying, so 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay, then here after calculating all those, we will get that number of line segments, and in the same way number of diagonals also we will calculate. For example, if that polygon is having that n sides, okay, n I taken it for n sided figure, so here polygon is equal to, for example, n is equals to n, n is equals to n, then number of line segments, how we can find? Again same process. The first number always we need to take it as n minus 1 only, no? 7-sided figure, 7 minus 1, 6-sided figure, 6 minus 1, okay, 5-sided figure, 5 minus 1, and in the same way n-sided figure, so n minus 1 plus n minus 2 plus n minus 3 plus, and in the same way, if you observe that one, here for example that is a 4-sided figure, then 3 plus 2 plus 1, 5-sided figure, 4 plus 3 plus 2 plus 1. So always it is ending with 1 only, no? In every case that figure is having that n number of sides, whatever it may be, always the last number always we are getting it as 1. Okay, why? Because we are taking the decreasing order. So decreasing order numbers up to 1, up to natural numbers only, no? Natural numbers starting from 1. So here it is ending with 1. Okay, that's why here the last one take it as 1. Okay, that previous number is 2, that previous one is 3, and in the same way. Okay, so this is for number of line segments. Now here number of diagonals, how we can calculate? Okay, this is number of line segments for n-sided figure. Now here number of diagonals, how we can calculate? Number of all or number of total line segments minus number of sides of a given figure. Okay, so here number of line segments means this one only, no? So n minus 1 plus n minus 2 plus n minus 3 plus and so on plus 2 plus 1. These all are number of line segments minus number of sides of a figure. So number of sides of this figure is n-sided figure. So minus n. So this is the formula to find for number of diagonals of a given polygon. Okay. Now here I will show you that every time, for example, here n is equals to n I am saying. For example, n is equals to 100. Then n is equals to 100. If that is a 100-sided figure, then that figure is having how many line segments? How we can calculate? Again same process. 100 minus 1 plus 100 minus 2 plus 100 minus 3 plus and so on plus 1. Okay, so 100 minus 1 is nothing but 99 plus this is 98. Just observe that 100 before number onwards, just we need to write every time, no need to write like that. Here 100 is there means we need to calculate from 99 onwards. Here 200 is there means we need to calculate from 199 onwards. Here 50 n is equals to 50-sided figure, then we need to calculate from 49, 48, 47, 46 and so on like that. Okay, so 99, 98, 97, 96, 95 and so on plus 2 plus 1. This is the most important. The last one must be ending with 1. For example, n is equals to 78. If that is a 78-sided figure, then how to calculate that number of line segments? Here 77 plus 76 plus 75 plus and so on up to 2 plus 1. If you add these all numbers, you will get the number of line segments are there in that 78-sided figure. Okay, and in the same way diagonals also. After calculating these all, okay, here you will get that one of the natural number. So that is minus 78. That is for number of diagonals. Okay, So every time like this 77, 76, 75, how we can calculate this all? How we can add these all numbers? For example, n is equals to 1000 I taken. Okay, that is a 1000 sided figure. Okay, here poly means many number of sides, infinitely many number of sides we can take. So for example, I am going to take here n is equals to 1000. Then how we can calculate those all? Again need to calculate that 999 plus 998 plus 997 up to 1. Is it possible to add these all numbers? Okay, it is possible, but it will take more time. I am not saying that it is impossible. It is possible, but it will take that more time, right? So that's why here we have that one of the formula to find that number of line segments of a figure, and in the same way number of diagonals also. Okay, here we have the two formulas. Let us discuss that how we got that formulas and what are those formulas. Okay, so here see the proof. Let here I am going to take that A1, A2, A3 and so on AN. A1, A2, A3 and so on AN are the vertices of a polygon. Are the vertices of a polygon or n-gon. N-gon or a polygon. Okay, here I taken that A1, A2, A3 and so on up to AN are that vertices of a polygon. So here I am going to take this one as like this one of the figure I taken. So here this is A1, A2, A3, A4, A5 somewhere. Okay, up to the last one is AN. Somewhere we will get that AN. Okay, so here how to calculate that number of line segments. Number of line segments. First I am going to take that the common vertex as A1. So first line segment is A1, A2. Okay, next A1, A3, next A1, A4, next A1, A5, A1, A6, A1, A7 and so on. The last vertex is AN be taken, right? So A1, AN. Okay, so what are those? A1, A2, A1, A3, A1, A4 and so on. A1, AN. Yes or no? These all are the line segments by taking A1 as the common vertex. Okay, so here always we know that 100 sided figure, the first number of line segments by taking one of that common vertex, that is 99. Yes or no? 100 taken means 99, 78 taken means 77. Okay, 90 sided figure means 89. So that is n minus 1 only, no? 89 is 90 sided figure means 90 minus 1 is nothing but 89. So that's why here the first one is n minus 1. Okay, number of sides minus 1, that is the first number of line segments, right? So next, here I am going to take that A2 is that common vertex. A2 is that common vertex. So A2, A1 already completed here. So A2, A3, A2, A4, A2, A5, A2, A6 and so on up to A2, AN. A2, A3, A2, A4, A2, A5 and so on A2, AN. Okay, so here we are leaving that how many vertices? 2 vertices we need to remove here, right? A1 and A2. Okay, we are not calculating that line segment. That's why here the second one is n minus 2. Okay, and in the same way the last line segment, what is that last line segment? That is nothing but AN minus 1 AN. For example, AN is equals to, this is for example n is equals to 6 sided figure, then here this is 6 minus 1 and this is A6. So the last line segment is A5 A6 only, no? Okay, for example that is n is equals to 4. So AN minus 1 means 4 minus 1. A3, A4. Okay, that's why here the last line segment is AN minus 1 and AN. That is the last line segment here, that is nothing but 1. Okay, previous what we written, that one only here again I am writing n minus 1 plus n minus 2 plus n minus 3 plus n minus 4 plus and so on up to 1. Okay, how you got that expression, just I am explaining this one. Okay, so in this method we got that n minus 1 plus n minus 2 plus n minus 3 plus and so on plus 2 plus 1. Okay, like this way we got that expression. Now here see that proof. Here sum of number of line segments means how many line segments are there. So while we are adding all the numbers, okay, 99 plus 98 plus 97 plus and so on up to 1, if you add all that natural numbers, then only you will get that number of line segments, right? That's why here I am going to take that S. S is nothing but sum of that numbers, sum of that first n natural numbers. Okay, we will this concept will come in the progressions. So just example I am saying. So S is equals to here sum of that numbers, sum of that first n natural numbers. That numbers must be in consequent order. Okay. So here S is equals to the first one what we got here, n minus 1 plus n minus 2 plus n minus 3 plus and so on plus 2 plus 1. That one only we got no previous. So that's why here now reversing. Reversing order. First I taken that order as 99 plus 98 plus. Here I am going to take that order as 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. If you add that all the numbers from 9 to 1, then also you will get the same answer. And in the same way, if you add that all the numbers from 1 to 9, in that reverse order also we will get that same number only or not? Same sum or not? Just for example, 4 plus 3 plus 2 plus 1, which is equals to here 10. Okay, now add the numbers in reversing order. 1 plus 2 plus 3 plus 4, then also you will get that the same result. If you add that numbers in any order, either from left to right or right to left, then also you will get that same result only. No, there is no change in that result. Okay, that's why here I am taking that one as the reversing order. First, given order I taken. Next, I am taking that reverse order. So here, when you are taking that reverse order, here I am going to leave that the first term. Okay, I am going to leave that the first term. Here onwards, I am going to write this is 1 plus 2 plus 3 plus and so on plus n minus 2 and here n minus 1. Okay, here we are leaving first term, that's why here we will get that the last term as that empty term. Okay, why? Because here the first term is empty, that's why here in that first series the last term is empty. Okay, while you are adding these two, equations, then you will get that S plus S is nothing but 2S. S plus S is equals to 2S. Already we learned this one in algebra, right? How to add that two variables. Okay. So here the first one is n minus 1 plus 0. No, this is no term is there means that is 0. So no need to add that. Plus the first one is n minus 2 and here this is a plus 1. Clear? Next term n minus 3 and here this is plus 2 plus and so on plus and here the last term and here last but not the least term, that is n minus 2 plus 1 and here the last term is n minus 1. Okay, so here this is n minus 1 plus n minus 2 plus 1 is nothing but minus 1. Minus 2 plus 1 minus 1 plus n minus 3 plus 2 minus 1 plus and so on. Here n minus 2 plus 1 is n minus 1 and here also n minus 1. To make that all the terms are equal, for that equal only here we left that one of the first term and here the last term. To make that equation as all the terms should be equal here. Okay, just we taken like this. Okay, after that here how many times n minus 1 term is there? Okay, here we don't know that, right? So for example 1 plus 1 plus 1 is there. 1 plus 1 plus 1 same number is in repetition. How many times that number is in repetition? 3 times. So 1 plus 1 plus 1 is nothing but 3 only, no? In another way also we can express this. What is this? 3 times 1 is in repetition. 3 times 1 is in repetition, that's why its result is 3. Why? Because multiplication is nothing but repeated addition. Multiplication is repeated addition. That's why here we can take that 3 into 1 also. Okay, so here how many terms are there? We don't know that. That's why here these are n terms are there. Okay, number of terms, n terms. N terms means n is equals to specific number. We don't know that. Why? Because how many terms are there? We don't know that. That's why here n terms are there. So n times the same term is in repetition. N times the same term is in repetition. So n times the same term is repetition means we can represent in that method, right? So we can write this one as n into n minus 1. N times n minus 1 is in repetition. Okay. So this is for 2s. So from this one s value we need to find out. So s is equals to n into n minus 1 by 2. N into n minus 1 by 2. So this is the formula to find for a number of line segments. Okay, this is the formula for to find a number of line segments. Is it clear? So here what is that formula? Number of line segments is equals to n into n minus 1 by 2. Okay, so use that formula and find that number of line segments. So already we simplified the triangle. No? Triangle is having that how many line segments? 3 line segments, and triangle is having how many sides? 3 sides. So just take that example. Here n is equals to 3 for example, then number of line segments which is equals to 3 into 3 minus 1 by 2. So which is equals to 3 into 3 minus 1 is 2 whole by 2. So 2 and 2 gets cancelled. Again we are getting the same number of line segments or not? Okay. So let us take that n is equals to 4. Then number of line segments 4 into 4 minus 1 by 2. So 4 into 3 by 2. 2 cancels 4 by 2 times. So 2 3 6. Yes or no? In previous method also we got the number of line segments of a quadrilateral is 6 only, no? So in this method also we got that 6. So by using this formula we can find that figure is having infinitely number of sides. Okay. For example, n is equals to 1000 sided figure. N is equals to 1000 sides. Then that figure is having how many line segments? Easily we can find that 1000 into 1000 minus 1 whole by 2. So 1000 into 999 whole by 2. 2 500 times. So 500 into 999. If you calculated these two, okay, 500 and into 999, then you will get that a number of line segments are there in that 1000 sided figure. Okay, now is it easy to use that formula? Okay, so no, every time no need to draw that picture, every time no need to calculate that how many line segments are there. Okay, by using that AB, AC, AD, okay, no need to, every time no need to calculate like that. So if they will ask that given picture or given polygon is having that how many sides or how many line segments are there. Okay, that number of sided figure is having that how many line segments are there, then easily we can use that the formula is S is equals to n into n minus 1 by 2. Okay, so number of line segments, what is that formula here? Number of line segments. What is that formula? N into n minus 1 by 2. So this is that formula we can use to find that a number of line segments. Now number of diagonals. Number of diagonals. How to find the number of diagonals? Yes, we know that number of diagonals is equals to number of line segments minus number of sides. Already we know this relation, right? Number of diagonals is equals to total number of line segments. If you subtract number of sides from that number of line segments, then you will get that number of diagonals. Already we know that relation. So here number of line segments formula is n into n minus 1 by 2. Okay, and here number of sides. Number of sides here we are taking it one as n. So number of sides is n. Okay, so from this one n into n minus 1, take that condition. Here 2 into n is equals to 2n whole by 2. If you subtract those two, you will get this one as n into n minus 1 minus 2 into n is equals to 2n and whole by 2. Why? Because LCM is 2 here, which is equals to n into n is equals to n square minus n into 1 is equals to n minus 2n whole by 2. Okay, so from this one, n square minus n minus 2n, that is minus 3n, minus n minus 2n, that is nothing but minus 3n whole by 2. Okay, so from this condition we can write it as, take n as common, so n into n minus 3 whole by 2, n into n minus 3 whole by 2. So this is the formula which one we can use for to find that number of diagonals of a figure. Okay, for example, that is a 3-sided figure, then 3 into 3 minus 3 by 2. So 3 minus 3 is 0. So 3 by 2 into 0 is equals to 0. We know that a triangle is having 0 diagonals. Okay, next, number of diagonals of a quadrilateral. Quadrilateral means that is 4-sided figure. So 4 into 4 minus 3 by 2. So 2 2's. So 2 into 4 minus 3 is 1. So which is equals to 2. We know that in a quadrilateral we have that only 2 diagonals. So we can use that these two formulas to find that number of line segments and the number of diagonals. So what is the formula to find that number of line segments? That is n into n minus 1 by 2. And the number of diagonals formula is n into n minus 3 by 2. Okay.